Hey, welcome to the Explainer. What if I told you the next huge programming language wasn't being designed for you or for me, but for the AIs we're building? Today, we're digging into KNA, a language built from the ground up for AI agents. And trust me, it completely flips the script on what a programming language is even supposed to be.
That one quote, it's really the key to everything about KARN. It's a direct challenge to, decades of programming philosophy. This is a pretty radical idea, so let's break down why this is such a big deal. So think about it. For the last 40 years or so, we've been fine-tuning languages for human developers. Adding friendly keywords, verbose syntax, all sorts of things to make code easy for us to read and understand. But what happens when the developer is a machine?
And this right here is the whole ballgame. For an AI, that context window isn't just a feature. It's its entire brain, its working memory. And every single thing you put in there, every word, every bracket, every semicolon, costs tokens. All that stuff we added for human readability, it's incredibly expensive for an AI, and it actively limits its ability to hold a whole program in its head and actually reason about it.
And just look at what that costs. A single line of Python chews up almost 7 tokens. Rust, over 11. This means an AI agent is burning through its very limited mental real estate just to process syntax and fluff that was only ever meant for human eyes. It's like trying to think with a dictionary strapped to your head.
All right, so that begs the question, right? What if we just threw all that out and started over? What if we built a language from the ground up, one that was optimized for how a machine thinks, not how a human reads? A language where every single character means something and absolutely nothing is wasted.
And that's exactly what KARN is. It's built on this idea of ditching human readability for something way more important for a machine: precision. For an AI agent, the goal isn't to write pretty code. The goal is to write efficient, provably correct code that it can understand and modify without any mistakes.
Okay, so how does this design actually help an AI agent do its job better? It really all boils down to one word: density. I mean, just look at this comparison. It's not even close. KARN clocks in at just 2.1 tokens per line. That makes it almost 4 times denser than Python. We're not talking about a small improvement here. This is a massive leap in efficiency for the AI.
Yeah, that number is really the punchline here. 76% fewer tokens. What that means is an agent can fit 4 times more logic, more context, more of the actual program into its working memory. And this isn't just about making things faster. It's about making things possible. It lets the agent solve way more complex problems because it can finally see the entire board at once.
But believe it or not, this crazy token efficiency, it's only half the story. KARN is also built to be a kind of universal translator, tearing down the walls between programming worlds that have been up for, well, forever. This is where it gets really powerful. An agent can cook up one KARN file, and that single file can become, well, pretty much anything. It can be a native C binary for a desktop app, it can be JavaScript for a server, or it can even be HTML and WebAssembly or WASM for a super fast app in a browser. It's all from one source file, which just obliterates the infrastructure complexity for the agent.
And check this out. This is what makes KARN so different from just another new language. It's not trying to reinvent the wheel. It can reach out and directly use all the mature libraries from Python's pip, JavaScript's NPM, even Rust's cargo. And the really important part is that it does this natively, without any of the slow, clunky workarounds we usually have to use.
So what does that actually mean? It means an AI agent gets instant access to decades of code that we humans have already perfected. NumPy for data science, React for UIs, you name it. It all runs in the exact same memory space as the KARN code. It's like giving the agent a master key to every programming kingdom at once. And the flexibility doesn't even stop there. KARN is also smart about how it runs the code, and it can switch things up based on what the agent is trying to do at that very moment.
Just imagine you're an AI agent, right? For those quick little tests, those fast trial and error loops, you'd use the interpreter, instant feedback. But for a server that's going to run for a long time, you'd use the just-in-time or JIT compiler, which gets smarter and faster the longer it runs. And then, when it's time to ship a final product, you just compile the whole thing down to a super fast native app.
So when you take a step back and look at all these pieces together, it's pretty clear we're talking about a huge shift in how we should even think about programming in the age of AI. The old rulebook, it's just not going to cut it anymore.
And this slide, this really sums it all up.
On one side, you have the languages we've always used. They're wordy, they have lots of hidden behaviors like exceptions, and they're designed to be easy for us to read. And on the other, you have KARN. It's minimal, it's precise, and it's designed for one thing and one thing only, to be correct. For an AI, that's everything.
And these are the features an agent actually needs to write solid code all by itself. There are no hidden surprises, no exceptions that pop out of nowhere. Building systems that do many things at once is the default, not an afterthought. And it has tools for resilience, like automatic retries, built right into the language itself.
So yeah, KARN leaves us with this really provocative question, doesn't it? Is the future of AI development going to be written in a language that most of us can't easily read? It might be that to really unlock what AI agents can do, we have to let go of our own need to understand every single line of code they write, and instead trust a language that was designed for them to get it right every single time. Now that's a future worth thinking about.